Okay, so the Pythagorean Theorem and trigonometry review from Math 10C. So Pythagorean Theorem is what? Yeah, so if I label a triangle, I label the corners, the vertices, the angles with uppercase letters, and I label the sides with the lowercase letter of the angle they're opposite. So if that's angle A, this is side little a. Angle B, side little b. And angle C gives us side little c. And then the Pythagorean theorem says that the square of the hypotenuse is equal to the sum of the squares of the other two sides, right? And then it can also be rearranged. So we'll do some examples where we're finding the hypotenuse. We'll do some examples where we're finding another side, right? But we're always going to set it up using Pythagorean theorem. Okay, and then the other thing we've got for right angle triangle trig is SOHCAHTOA, which says that the sine of an angle. Okay, now it's the sine of something, right? Don't just write sine equals, because that's not true. It's the sine of an angle. Sine, and usually in trig we use theta, okay, as sort of an unknown. But it could be x, y. It'll be labeled. It could be angle b, whatever. Cos of theta is adjacent over hypotenuse, and the tan of theta is opposite over adjacent, right? So sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. That's the k, and toa, tan is opposite over adjacent, right? And then the big thing is just when we go to solve the triangle, we have to name the sides properly, right? So always start by identifying the hypotenuse, because it's the easy one. Where's the hypotenuse? Longest side. And what's it opposite? The right angle, okay? So we look for the right angle and identify the hypotenuse. So in this case, x is the hypotenuse. We've only got the sides, so we're using Pythagorean theorem. Okay, so we'll say that x squared is equal to 15 squared plus 20 squared. And one thing we know is when we get a value for x, it has to be larger than 15, and it also has to be larger than 20, right? Because it's the longest side. So x squared is equal to 225 plus 400. X squared is 625. What's x? 25, right? We do the square root. Now, either you get it as an exact value, so in this case, it is an exact value. It's 25. It's 25 meters, right? Because there's actually units on this. So one thing we want to remember solving a triangle, sometimes we're just getting sides and angles, and sometimes we're getting sides and angles that have units with them, right? In this case, the unit is meters. Okay. We don't always have units associated with it. Okay, so in this case, we could see the hypotenuse is the 10, right? So we're going to set this up as x squared plus 6 squared is equal to 10 squared. Okay, so in this case, I'm putting my unknown on the left-hand side, which I did here, right? But writing x squared equals, I'm putting my unknown on the left-hand side, which means that x squared is equal to 10 squared minus 6 squared, okay? So if you're figuring out one of the other sides, there's going to be a subtraction operation going on, right? Because we know this is the longest side. So x squared is 100 minus 36, which is 64. And so x is 8 centimeters, right? So in this case, there's a unit associated with it, which is centimeters. Okay, so that's Pythagorean theorem solving for the hypotenuse, longest side, and your check is just to make sure, is this number larger than either of these two? And solving for another side, is this side smaller than the hypotenuse? Okay, questions on Pythagorean? Yeah, my moving thing is off it's off the smartboard. Determine the measure of the indicated angle in each triangle to the nearest tenth of a degree. Okay, so the whole secret to using trig to solve for angles is naming the sides of the triangle, right? And hypotenuse is easy because it's fixed. This is the hypotenuse. But the other two sides are named in relation to an angle. So this is angle A. What's the name of this side? This is adjacent. What's the name of this side? Opposite. So what we have to say is, all right, angle A is what I want to find, and the things I know are opposite and adjacent. Which trig ratio relates opposite and adjacent? Tangent. So let's start off by putting down the formula. So the tangent of angle A will be opposite over adjacent. Okay, and that communicates a couple of things. One, you're using the correct angle. Okay, using the correct ratio, right? I'm using tangent, so I need opposite and adjacent. So you've identified the ratio. So the tan of angle A, so now we can substitute in, is 7.1 over 10.2. Now how do we get the angle? Because it's A we want to find, and we know the tangent of angle A. Yeah, we use inverse tan, right? So to solve for A, you take the inverse tan of both sides, and the inverse tan of the tangent of A is just A, right? So inverse tan basically says undo the tangent. And inverse tan says, give me the angle whose tangent ratio is this. Okay, and to the nearest tenth of a degree, what is that angle? 34.8. 34.8. So A is equal to 34.8 degrees. Okay, so make sure that you're rounding correctly. If we know we're doing nearest tenth, we can just set the calculator besides mode. Degrees, you can also go to mode, and instead of float, change it to 1. That way it'll round to 1 decimal. Okay, and then we go tan inverse 7.1 divided by 10.2. Calculator rounds for us. We don't have to worry about rounding incorrectly. Okay, in relation to, so before we do with relation to angle B, what's the name of this side? This is hypotenuse. In relation to angle B, what's the 10 meters? Opposite. Which ratio relates opposite? Sine. So we say the sine, the sine of an angle, right? It's the sine, the cos, or the tan of something. It's not just sine equals, right? So the sine of angle B is opposite. So I'm just giving you formula, right? Sine is opposite over hypotenuse. That lets me know two things when I'm looking at your solution. You're using the correct ratio, right? And you've identified the sides, right? And it's always a good idea to write in the names of the sides here. Okay, so the sine of B is opposite, which is 10, over hypotenuse, which is 12. This has to be larger, right? The 12, the hypotenuse. So what's B equal to? Okay, so we have to do inverse sine of 10 over 12, which is 66.4. 56.4. And big thing with angles is they must be labeled with a degree symbol, right? So don't leave out the degree symbol. Could cost you marks. We got a little problem here because you don't want a triangle that has meters and millimeters. So let's make this millimeters here. Okay, so if you are dealing with a triangle, make sure that the measurements are in the same units. Okay, we'd have to convert that 12 meters to like 12,000 millimeters, and then off of that we're going to draw a little 14. That's not what we're looking at here, right? First of all, we know the 14 is the longest side, right? It's hypotenuse. So, you know, we left off a little m in here. Okay, this is hypotenuse. This is the angle. What's the name of this side? Okay, so this side is beside or adjacent to angle C, so it's adjacent. Which trig ratio are we going to use? Okay, so we say the cosine of theta, or actually C in this case, right, because we know it's angle C. The cosine of angle C is adjacent over hypotenuse. Okay, write that down. I know it's a little extra step. It doesn't use that much of your pencil, right? You can always find them in the hallways or all over the place. Okay, so like if you need a pencil, they're around. Okay, cosine of C is 12 over 14. How do we get angle C? Inverse cos, and that is what? 31? 0.0?
Yeah.
0.0. Okay, so if they say nearest tenth, then we want to see a 0.0. Okay, but even if it says nearest tenth, you need to give that decimal. Determine the measure of the indicated side in each triangle to the nearest tenth. You must show your work, i.e. the trig ratios used. Okay, this time we're going to use trigonometry and we're going to solve for a side measurement, right? So we used it to get angles, right? So what have we've done Pythagorean Theorem. Okay, Pythagorean Theorem to find the length of the hypotenuse, the length of another side. We've used the sine, cos, and tan ratio to find an unknown angle, and now we use sine, cos, and tan to find an unknown sine. So we have 43 degrees here, that's the angle. What's the name of this side? Hypotenuse, right? And that's always really the first side you should identify, because it doesn't matter where it is, you know, which angle, whether we're talking about this angle or this angle, that's still the hypotenuse. Right? Because the other two angles, the non-right angles, they're adjacent to the hypotenuse, right? They're part of it. So we can't really call that adjacent because we need to save adjacent for, in this case, the x. That's adjacent. Okay? And if you want, you can label this as opposite. Okay? So we label the three sides of the triangle. One side is fixed. It's hypotenuse. It's always hypotenuse. Doesn't matter what other angle we're talking about. The other two sides, it depends on the angle. Okay, which ratio are we going to use? Cosine. So let's put down a formula. The cos of theta is adjacent over hypotenuse. The cosine of 43 degrees, so we're substituting in, right, is equal to x over 8. Now, how do we isolate the x? So what's happening to the x? It's being divided by 8, so how do we undivide? So we're going to multiply both sides by 8, right? So the idea is, what's happening to my x? It's being divided by 8. Okay, let's multiply both sides by 8. So the x will become by itself, and you'll end up with 8 times the cosine of 43 degrees. Okay, rounded to the nearest tenth. Right, and I've got my calculator set to round, so what do we get? 5.9. What are the units?
Centimeters.
Centimeters, correct. Okay, same thing. First thing we're going to do is identify the sides. This is the hypotenuse. In relation to the 67 degrees, what's the 7 meters? Adjacent. And what's the x? Opposite. Okay? This is a big thing, right? If you name the sides wrong, it's all wrong from that point forward, right? I mean, you use the wrong ratio, you use the wrong numbers, it just doesn't work well. Okay, so we've got adjacent and opposite. Which ratio do we use? Tan. So let's start off with a formula. The tan of theta is opposite over adjacent. The tan of 67 degrees is x over 7. How do we get x by itself? So we multiplied both sides by 7. So then x is equal to 7 times the tangent of 67 degrees, which is 16.5 units? Meters.
I got 18.2.
Let me give it a try. 7, 10, 67.
Oh, never mind.
Yeah.
I did 69 better.
Okay. No worries. Okay, 16 millimeters. What's the name of this side? Hypotenuse. In relation to the 25 degrees, what's this side? Which ratio do we use for opposite hypotenuse?
Sine.
Sine. So let's start off just by writing down a formula. Sine theta is opposite over hypotenuse. Right? If I see you using cosine, I know this is not going to work out well, right? Like, you're not going to have a correct answer there. I might as well just put a big X through it and say, no, sorry, use the wrong angle. So the sine of 25 degrees is equal to x over 16. What do we do to get the x? Multiply both sides by 16, right? So far we've been lucky with working these out, right? Okay, and what do we get? 6.8. What units? Millimeters. Okay, any questions on these three? So there's another few. Okay, again, so what I want you to do is name the sides, right? Name the sides in this before I write down the names of the sides. And do it for all three of these. Write them down. Which one's hypotenuse? What's the name of these sides? In relation to the angle that is shown. Okay, so play a little game of name those sides. Right. Once the sides are named, we use SOHCAHTOA, figure out which ratio we're using. We plug in the numbers and we solve. Okay, which ratio are we going to use here? Cos. I hear more coses than tans. Yes. Okay, so let's start off by saying cos theta, right? We're just going to use general formula. So all I'm doing, and if you're writing this down and somebody else is looking at your solution, if they say, hey, can I see the answer to that one? Then they're going to see, oh, they use cos, and it's like, oh, I use tan. One of us is wrong, right? Or we're both wrong. Maybe it's supposed to be sine. But you got to figure out which one, right? And then ask the other person, why'd you use cosine? Because I think you have this and this. And they say, no, 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 if the side is this. And oh, okay. So you need to, you need to be able to explain it to somebody else. And by starting off with cos theta, then looking at it, they can say, okay, yeah, I got cos theta, same as you. So now I'm going to fill in. So I've got cos of 46 degrees is equal to adjacent, which is 21. So hang on, cos is adjacent over hypotenuse. Somebody said tan at the beginning, right? I said, what ratio? Tan. Okay, so adjacent 21 over x. Okay, here's the problem. Unlike the first three, the thing we want to find is on the bottom. So how do we do this one? Divide. Okay, so here's what we can do, right? We're going to do, so when I do these three, which I think are all going to work out kind of the same, I'm going to do them all the same, and then we'll look for a shortcut. So first we do multiply both sides by x. Just like we did before when the number that we knew was here, and the number we wanted to find was up here, and the number we knew was down there. Okay, so multiply both sides by x, and then say, but to get x by itself, it's 21 divided by cos 46. Okay, so worst that takes one more little step, right? You have to multiply both sides by x and then divide both sides by cos 46. Okay, and then I'll show you the trick in a minute. But what's 21 divided by cos 46? 30.2. Units? Centimeters. Okay, there's a little bit of a check, which is it's larger than the 21, okay, which it should be because it's the hypotenuse. Okay, I don't really know that it's correct, but I do know it's larger than this, and that at least it tells me if this were smaller than that, there'd be a problem. I would have used the wrong ratio. Okay, so before we do anything here, just write down your formula. So write down the formula you're going to use. Okay, sine, cosine, or tan. So which formula are you going to use? All right, so which ratio did we use? Use the sine, so sine theta is opposite over hypotenuse. Sine, now we substitute in 73 degrees is 9 over x. My unknown is in the bottom, right? So I'm going to multiply both sides by x. So x times the sine of 73 degrees is equal to 9. Okay, it's one little extra step, right? But it's the difference between getting it right or getting it wrong. Okay, so do the one little extra step. All right, and what is 9 divided by sine 73?
9.4.
9.4. Units?
Meters.
Meters. Okay, so do this one. You guys should be able to just do this one. Okay, so I'll give you 20-second head start. Figure out what ratio you're using, write that down, substitute in. Okay, you should be ahead of me. Not- And what do we get?
2.1.
2.1? Okay, 2.1 meters. Okay, so that x value should be, well, I mean, should it be smaller? Well, let's start thinking about this a little bit. Think about properties of angles and triangles and stuff, right? So I've got the 90 degrees here, and we know the longest side is opposite the 90. Well, because it's the most wide open, right? This is 81 degrees. I mean, this is not 81 degrees here, right? So remember, diagrams that you see in textbooks, or textbooks are probably a little more accurate, but diagrams that you see on a test or that I draw on the board, they're just a placeholder for information, right? All that's saying is, hey, that angle's 81 degrees. That angle's not 81 degrees, right? If we measure it, it's not 81. So if you think about it, if the largest side is opposite the largest angle, then the next largest side, the middle of the three sides, has to be opposite the next largest angle, right? And then the smallest side will be opposite the smallest angle. This is really only 9 degrees, right? So this is going to be a fairly small side, right? If you think of opening. And 2.1 seems reasonable, right, as a fairly small side. If these were like both 45, then 2.1 doesn't make a lot of sense, right? You'd say, well, I know these sides are the same, and it can't be that small. Okay? So, largest side is opposite the largest angle. The smallest side is opposite the smallest angle. And there's only one thing using deductive reasoning that follows from that. Right, which is the middle side. Oh, now I was going to show you the shortcut. So the shortcut, if you're solving something like this, is that you can go directly to that step. What you're basically doing is interchanging these two guys, right? And the reason you're doing that is you're cross-multiplying. You're multiplying both sides by x and then dividing both sides by cos 46. So if you want the quick way, you just interchange the x and the sin 73, and here you interchange the x and the 13.1. Okay. Now, if you can remember that and do it properly throughout all of your homework, fine. If you're starting to get them wrong in your homework, then just go back and put in that one extra line, right? It doesn't take much to write that one extra line. X times the cos of 46. Okay, because a lot of people will get this wrong. All right, you'll do weird things. I don't know what you'll do, but it'll be something weird. Determine the measure of the indicated side in each diagram to the nearest tenth. You must show your work, i.e. the trig ratio used. Okay, so here's the problem, right? I want to find x. So I got this 41 degree angle. I've got this 90. I could calculate this angle if I wanted to, but I'm not going to at the moment. But I don't know any other measurement inside this triangle, so I can't find this length, right? I do know that x is the hypotenuse of this triangle here, right? The purple triangle. I know that x is the hypotenuse of that triangle. But I need one other piece of information. And in this case, we're going to go to this triangle here. We'll do that as red. Go to the red triangle here. And we will figure out this length, which we will call little a. So this is a two-step procedure, right? We have two right triangles. In this case, they joined with a common side. We're going to use trig to figure out the measure of side A, and then we will use trig again to figure out the measure of side X. We will not round the A. Okay, we will leave that in our calculator. When I write it down, I'll show you what I write when I write it down. So let's just start off. I've got 62 degrees. I know that the 21 is the hypotenuse, and what's little a?
Opposite.
That is opposite. Which trig ratio am I going to use? Sine. Okay, so here's how we start out. Sine theta is opposite over hypotenuse. Now we fill it in, right? Because we're trying to communicate what we're doing. So the sine of 62 degrees is little a over 21. Okay, now we're going to show some work, right? So a, little a. Thank you. Little a is 21 times sine 62. Now, in a sense, I don't even have to really work that out. Okay, and I may not want to work that out in my calculator yet. I just say I need little a. Okay, but I have an expression for it. I could throw that in brackets. So now we go over to the second triangle. And we say, okay, that's the hypotenuse, but in relation to the 41 degrees, what's little a? Okay, it's also opposite. So we'll go over here, we'll say sine theta. We're just repeating. Sine theta is opposite over hypotenuse. But this time we write the sine of 41 degrees is little a over x. And we say, I already have an expression for a, right? I'm saving it. I'll use it in a minute. So I need to rearrange. So I'm going to go x times sine 41. Remember, x is what we want to find, and a is what we already have, right? We have an expression for a. So x times sine 41 is equal to a. So x is equal to a divided by the sine of 41 degrees. So let me just pull up a calculator here. Okay, so you turn that on. So mode, got to go to degree mode. Did they say what to round to here? Nearest 10? Okay. So I won't bother saying, but how you would set to nearest 10th is to go up to float and go on to the 1, right? I'll leave it. We'll just do the rounding on the fly. Okay, so I want little a divided by sine 41. So x is equal to 21 times the sine of 62 degrees divided by the sine of 41 degrees. Okay, so what's that going to look like? Well, I'm going to put down a bracket and say 21 sine 62. Okay, now I got to close that bracket twice, right? So there's 21 sine 62. Calculator's going to work that out first, divided by sine 41. Close that bracket. Whoops. And close that bracket and hit enter. 28.26, so 28.1? 3. So x is equal to 28.3 what? There are no units on there, right? So all we do is just say x is equal to 28.3. Okay, now, here's where you can go wrong in this. Here's the mistake people make, is they'll work out a, right? So they'll go, okay, a is 21, so 21 sine 62, close that, hit enter, right? Look at 18.5. Then they'll write this down as 18.5. And then they'll use 18.5 over here, right? So they'll go, okay, it's going to be 18.5, so they'll go 18.5 divided by sine 41, hit enter, and get 28.2. And you're going to be wrong, okay? Because in numerical response, so if it's multiple choice, you probably won't get that as a choice, right? And they won't be that close together, so you'll be okay. So, the closest thing I got is like a 28.3. If you want to do it that way, right? And here's what you can do. You can go 21 sine 62. Enter. Then you go over to here and you say, okay, I need to get x, I need a divided by sine 41. There's a, so I'm just going to go divided by sine 41, and then I'll get my 28.3. Okay? So the big thing is do not round. Don't round this value and then use a rounded value over here. You'll get it wrong. Okay, you can use the values in the calculator. So it's all right if in this solution you wrote over here and you wrote A is equal to 18.5 dot dot dot, right? Showing that I'm going to use the full amount. And then over here, you got to here, instead of A, you wrote 18.5 dot dot dot, right? And then worked it out and got to this. Okay, so that's an alternate way of doing that question. All right, now here we have two right triangles. One big triangle, or the left triangle, that's this guy here, and the right triangle, which is the bigger triangle. And we just want to figure out one piece, but it's not even a piece of one of the triangles, right? Like this, this is a piece of kind of this triangle, right? This oblique triangle. We can't solve oblique triangles though, right? That's not a right angle. This triangle here, you know, that x is a piece of that triangle. We can't solve that. So how are we going to do this? Solve for the whole length on the bottom first. Let's call that A. And what else are we going to solve for then? So the opposite side of 66, let's call that B. Well, do I need, if I've got these two pieces of information, do I need the big hypotenuse? No, right? So what's x equal to in this case? A minus B, right? So if we can figure out this little guy, which we can because we got 66 and 30, and if we can figure out this whole one, which we can because we've got this 73-degree angle and the 30, we figure out B, we figure out A, we go A minus B, we get x. Okay? So we could do this way. We could write x is equal to B minus A. And now we can go up here and we can say, all right, so little b, what's the name of b? Yeah, that would probably make more sense there. Okay, so how are we going to find little a? So here's our angle that we have. Little a is what relationship to this angle? It's opposite. And what's this side in relation to this angle? Adjacent. So we're going to use tangent, right? So little a, well, hang on, let's do it this way. So tan theta is opposite over adjacent. So the tan of, so if we want to do little a, what angle are we using? 66 or 73? Okay, so we say the tan of 73 degrees is little a over, what's the adjacent side? 30.
30.
Okay, they jump in at the end, right? 30, yes, like she said a minute ago. So a is equal to 30 times the tan of 73 degrees, right? Okay, we're going to do the exact same thing, only with 66 degrees and b. So the tan of 66 degrees is little b, also over 30, right? We're in this triangle here. Okay, so b is equal to 30 times the tan of 66 degrees. So now we have expressions for a and b. We know what x is. It's a minus b. So we're going to say x is equal to 30 times the tan of 73 degrees minus 30 times the tan of 66 degrees. Okay, and we'll just enter that in our calculator. So 30 times the tan of 73 degrees minus 30 times the tan of 66 degrees. So 30.744, 30.7 rounded to the nearest 10th. And the units are meters, right? Okay, so that makes sense. We have to solve two, we're using two right triangles, right? That's a review of grade 10 trig. Grade 10 trig, we did two right triangle solutions. Okay, so now we're going to look at examples of Pythagorean Theorem and basic trig, or some more examples, I guess. And, wow, we got, like, what, 10 examples? Okay, so I need to get rid of these things. So if A, B, and C are the lengths and sides of a right angle triangle, and C is the hypotenuse, then A squared plus B squared is equal to C squared. And we've got SOHCAHTOA listed here, sine definitions for sine, cosine, and tangent. And let's move into the examples. Given the right triangle below, so it says it's a right triangle, and so we're going to label this, right? Because if there's a right angle in there, it is angle C. To determine the length of side AB. So this is the hypotenuse, right? So this is Pythagorean theorem. C squared is A squared plus B squared. So determine the length. So all you can do to get the length, since we don't know any angles, right? We can't use any trig ratios for angles to solve for length. So C squared is, so this guy here is little a. Remember the naming convention, right? Angle A, this guy's little a. C squared is A squared plus B squared, so 3.2 squared plus 1.9 squared. Determine the side length of AB to the nearest tenth. So that's 10.2. That's 3.6. That's C squared, so that's going to be 13.8. Oh wait, have I got round? No, I didn't start rounding. Okay, and then take the root of that, and we get 3.7. Okay, 3.7 what? Inches. Then it wants the trig ratios to the, and that's exact, right? It is exactly 3.7. It's not, or did I set this? Oh, I set this thing to round. Hang on. Right. So I got to go back to float. So you got to watch out if your calculator's on float or round. So 3.2 squared. So that's 10.24 and 1.9 squared. That was 3.61. So that'll be plus is 13.85. Right. Okay. So that's 3.7. So length to the nearest tenth is 3.7 inches, but the value is different, right? So state the three primary trig ratios rounded to the nearest thousandth. Now, it doesn't say the three primary trig ratios of which angle, right? So we've got two angles we've got to work with, angle A and angle B. Okay, so in relation to angle A, this is opposite. This is opposite to angle A, and this is adjacent to angle A. And this is the hypotenuse. Regardless, it's the hypotenuse, right? And if I'm doing stuff to the nearest thousandth, then I want to keep my little c value, right? So if we say the sine of angle A is opposite over hypotenuse, so the sine of A is opposite, which is 3.2 over the 3.72 dot dot dot. Okay, so we got to keep this number in our calculator. Right? So let me just work that out. So it was the square root of, so you can get there directly, right? It was the square root of 3.2 squared plus 1.9 squared, which is 3.72, 155, 85, etc. Okay? So I'm going to use that number, and I'm going to store in A. Right? So when I use little a now, or when I use A, I'm going to get this value, right? The unrounded value. So the sine of angle A is 3.2 divided by A, or 0.8598. They want thousandths, so 0.860. Okay, so that's the sine of angle A. Cosine of angle A. Cosine is adjacent. Let's move that up here a bit. So cos is adjacent over hypotenuse. Cos of A will be 1.9 over 3.72 dot dot dot. To go back here, so I go 1.9 divided by alpha A, and I get 0.511. And the tan of angle A is opposite over adjacent. And we already got opposite and adjacent, right? It's 3.2 over 1.9. And that is 1.684. Okay. Example 2, if the side opposite to angle B in a right triangle is greater than the side adjacent to B, the angle B is. The side opposite to angle B in a right triangle. Let's do this. So here's a right triangle. Is greater than the side adjacent to B. So let's put angle B here. So there's the side opposite to B. This is adjacent to B. This is the hypotenuse. So what can we say about angle B? One wants us to say something about angle B.
So we just do that.
Okay, which ratio uses opposite and adjacent? Tan. Okay, so we say the tan of B is opposite over adjacent, which means B is the inverse tan of opposite over adjacent. So we could say, well, what's going to happen if they're equal to each other? Right? So what if I do inverse tan, and I make those two sides equal? Let's say they're both 5, right? 5 divided by 5. I get 45 degrees. Now, let me make the opposite side bigger. So what happens if we go tan inverse, we go 6 divided by 5? Will I get a number bigger than 45 or smaller? We get a number that's bigger. Okay? So then we know that angle B is greater than 45 degrees. Be greater than 45 degrees. Given triangle ABC, determine the length of side AC to the nearest tenth and the measures of angles A and angle B to the nearest degree. So we need this side. Side AC is little b. The 11.4 is little a. And this is little c. Where's the right angle? At A, at B, or at C? Yeah, well, all we've got to go by is this is the longest side. It sure looks longer than this side. So we'll put this as the right angle.
Do we have to prove that this generation?
No, because they said you're given the right triangle ABC. Right? And B sure as heck doesn't look like the right angle. No, finding the sine. Determine the trig ratios. Okay. Well, here was a question back about example 1. It's actually kind of important, so let's look at that, and then we'll end and pick up tomorrow. So, example 1 said the three primary trig ratios rounded to nearest thousand. So, it didn't ask us to work out angle A. It asked us to get the sine of angle A the cosine of angle A and the tangent of angle A. So there's a difference between work out the trig ratio and work out the angle. If I wanted the angle, I would do A as the sine inverse of this. But we didn't want that. We wanted the actual trig ratio rounded to the nearest thousand. Okay? All right, so let's end there. We'll pick